Hey guys, welcome back to Clear Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 2 to the power of 10 minus 2 to the power of 9. Now what I'm first going to do is I'm going to rewrite this 10 as 9 plus 1. So we have 2 to the power of 10 minus 2 to the power of 9, and this is equal to 2 to the power of 9 plus 1 minus 2 to the power of 9. Now, an important property of exponents is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So the base simply distributes with the exponents. So I'm going to use this property for 2 to the power of 9 plus 1. We can think of 2 as a, 9 as m, and 1 as n. So this would equal to 2 to the power of m, which is 9, times 2 to the power of n, which is 1. And now we are subtracting this with 2 to the power of 9. And now this is equal to, now I'm going to factor out 2 to the power of 9 from this. So if I factor out 2 to the power of 9, I get 2 to the power of 9 times, now 2 to the power of 9 divided by 2 to the power of 9 is 1. And then I have, 2 to the power of 9 times 2 to the power of 1 divided by 2 to the power of 9 is simply just 2 to the power of 1 minus 2 to the power of 9 divided by 2 to the power of 9 is 1. And now this is equal to 2 to the power of 1 minus 1 is simply 1. So I have 2 to the power of 9 times 1, which is equal to, anything times 1 is itself, so 2 to the power of 9. Now for 2 to the power of 9, this is equal to 2 to the power of 4 times 2 to the power of 5, because remember, a to the power of m plus n, a to the power of m plus n is equal to a to the power of m times a to the power of n. So now 2 to the power of 4 is 16. 2 to the power of 5 is 32. So we have 16 times 32. We have 32 times 16. 2 times 6 is 12. We carry the 1. 6 times 3 is 18. 18 plus 1 is 19. Then we add our 0. 1 times 2 is 2. 3 times 1 is 3. 2 plus 0 is 2. 9 plus 2 is 11. We carry the 1. 3 plus 1 is 5. So our final answer is 512. Hey guys, welcome back to Clear Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 8 to the power of x is equal to 80. Now the first thing I'm going to do is I'm going to rewrite 80 as 8 times 10. So we have 8 to the power of x is equal to 8 times 10. Now notice how we have 2 8s on both sides. And what I want to do is I want to move this 8 to our left-hand side. And the only way to do that is to divide both sides by 8. So if I divide both sides by 8, I get 8 to the power of x divided by 8 is equal to, these two cancel out, so I'm simply left with 10. Now this 8 here is the same thing as 8 to the power of 1, right? And now if we have something in the form a to the power of m divided by a to the power of n, this is equal to a to the power of m minus n. So a to the power of x divided by a to the power of 1, we can think of a as 8 here, x as m, and 1 as n. So if we plug this in, we get 8 to the power of x minus 1. This is equal to 10. Now 8 here, this is the same thing as 2 to the power of 3, right? So I'm going to rewrite 8 to the power of x minus 1 as 2 to the power of 3 to the power of x minus 1 is equal to 10. Now, if I have something in the form a to the power of m to the power of n, n, this is the same thing as a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, this is the same thing as 2 to the power of 3 times x minus 1 is equal to 10. Now we have to simplify this, so we're going to distribute the 3. So this would be 2 to the power of 3 times x is 3x minus 3 times 1 is 3. Now this is equal to 10. So now we have 2 to the power of 3x minus 3 is equal to 10, and now I'm going to take the log on both sides. So now I have log 2 to the power of 3x minus 3 is equal to log 10. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b, right? Well, we can actually move our exponent b here to the front of the logarithm. So this would be equal to b times log a. And this is an important property because let's say we have some 2 to the power of x is equal to 5, right? A simple exponential equation. Well, we can just take the log on both sides, so we can move this exponent x to down, because we can't solve this equation if x is an exponent. We want it to be a real term. So that is why this property is so important. So in this case, as you can see, x in this case is an exponent. It's not an actual term. And if we want to find the value of x, we want x to be an actual term. So I'm going to use this property here and move our exponent here, 3x minus 3, to the bottom. So now we will have 3x minus 3 times log 2 is equal to log 10. Now, because we want to find our value for x, we're going to have to isolate it. So we can do that by first dividing both sides by log 2 to move our log 2 to our right-hand side. So then these two cancel out, and I'll be left with 3x minus 3 is equal to log 10 over log 2. Now, the value of log 2, this is equal to 0.301. And log 10, this is the same thing as 1, because any logarithm always has a base of 10. So this is the same thing as log base 10 of 10. And this is essentially asking 10 to the power of x is equal to 10. So what is x? And x is equal to 1, right? So log 10 is equal to 1. So now we have 3x minus 3 is equal to 1 over. Now log 2 that is equal to 0.301. So we have 1 over 0.301, sorry. So 3x minus 3 is equal to 1 over 0.301. Now, 1 over 0.301, this is equal to approximately 3.3223. So now we have 3x minus 3 is equal to 3.3223. So I can simply add 3 on both sides. So now I have 3x is equal to 3 plus 3.3223 is equal to 3.223. Now I can divide both sides by 3 because we want to isolate x. These two would cancel out, and I would be left with x is equal to 6.3223 divided by 3 is equal to approximately 2.1074. So x is equal to 2.1074. And now, remember our original equation was a to the power of x is equal to 80. So if I plug in 2.104 into my calculator, so let's a to the power of 2.104, let me plug that into my calculator. So 8 to the power of 2.104, and yep, it is indeed approximately equal to 80. Because it's not the exact value of 80, but it is approximately equal to 80 because they